Good afternoon, everyone. Yeah,
Afternoon, sir. Good
no
afternoon, sir.
afternoon, no Charlene. I'm not giving it the day off. Aviana,
Sir, is the mommy asking and I
Yes,
telling
yes,
them
see
that
that,
you're not
Charlene.
going
You
into
see
the
that?
week,
You see
sir.
that? You see that, Charlene?
no Charlene, don't make them man angry here, Charlene, because you're gonna say you asked me because you have sir favorite, right? No, Charlene, you say all if for 1 minute to class me and log on. No man, guys. It's just today is just a. I did tell you there now because I kind of sensed what the day was going to be like, but just mash up, man. When I say mash up, mash up, mash up, mash up. But anyhow, I trust that you all are well. I recognize it's just 10 of you.
Sir, I give
Um,
the day off. You can relax your brain.
no, Kels,
I know it.
you're too sweet. You're too sweet. We don't want no day off from you. When you the day off next week, Tuesday.
You're funny, you know, sir. You're funny. School good.
Rest your mind. Oh, goodness. Room look
Sir, you
full,
know, funny
full
enough,
of
my come
nobody.
class plan for keep quiet.
You serious? But
Yeah,
that
I
can happen.
feel good, sir. I don't feel
You,
good.
you know feel good what?
I'm sick, man.
Oh, Jesus us. You hear the doctor tell us if we go chuck off in our hole and lock up?
No, sir. The doctor, alright, you know. I don't feel sickness make me sick.
Okay, alright then cool. Alright.
And never you need the doctor tells you, you know.
Eh,
Hey, me never mean, cause me nah go see no doctor in these times. Me sick.
why?
Try
Why?
and fasting. Olive oil, only olive oil anointing.
See me so. See me so. I would just be very concerned right about now with this COVID something, and I was listening to the news at 5 o'clock because I was gonna log on at the class tab and I said, oh God, I said, God, only God see and know how I feel. And then I heard rather not saw, I heard where they say the the new strain of the COVID is more than likely in many other countries. It's just a matter for them to detect it and that it is more deadlier than the others. It's spreading faster rather than the others. And I'm saying, no, Lord. So they are saying that even the vaccinated um, will need to be very careful because of the seriousness of this one here. What to do? What to do? Because we still have to live. We still have to go to supermarket. We still have to go a road. We have to do road still. What to do? You have to work. We just have to do what we need to do. Just protect ourselves and social distance. And importantly, I think the best thing, in my view, for this darn COVID-19, I hear somebody say they should have been COVID 21 no kites. They didn't grow. But I think the best thing for this thing is just to wear your mask. I'm not calling down any sickness on myself, but normally every year, at least once for the year, no more than 2 times for the year, I will come down with the common cold. Try as I may to keep safe from everyone and walk up and down medical sanitize and sanitize, one or 2 times. I will come down with the cold. You say from COVID come in, you say through me I wear mask every day. I'm good as gold. No flu. And I'm saying to myself, this is the best antidote for this darn virus. But something is on my mind and I need to share it with you guys. And before we begin, um, so late last night after teaching a class, last night was Monday, yeah, after teaching a class, and I went on a bed, lay down a little. Well, mm-mm, me get 2 hours sleep out of it. I wake up at ministry 11 o'clock. A student sent me something about the young lady that was murdered downtown. Let me tell you something. There's something mash up my meds. Bad, 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 bad. It's like me know the girl. Mash up my meds. Bad, bad, bad. And up to today when I was in the meeting, vetting session, I kept looking at her picture. Yeah, coming morbid. And I'm saying, just look at what is man. She's here pregnant. Somebody murdered her, and she's just lying in the road. Lying in the road, the dirty, dirty road. Some roads I don't even want to walk on, let alone for my body to be lying. Oh God, guys, let me tell you something. I'm also aware that you don't have to do anybody nothing for them to hurt you. It's just who we have become, a generation of vipers. There's no love in our heart. Nobody can say nobody love them anymore. The father can't say to his son, I love you, son. Or else ever hear say, the father gone and he might train his son to be somebody else. And it is just wrong. I feel say them people out here say don't have no love. And as Miss Kitty would have say, they never get no breast milk. No breast milk. Them don't have no mother's love. The man them wicked, man. The man them wicked. The man them evil. And just to think about it, the man them can pay you $3,000 to take you out. $3,000 to take you out. What is life? What is man? So the truth is, as you guys have started your bachelor's this semester, you still have some time to go as evening students. You have what, 5 more semesters after this? When you would have completed, bad man people are go out there, and I'm gonna say, sure, you get a degree, you're going like you're better than them. Well, damn right. You have your degree, them not have none. But be careful. Be
That's why I have to
careful.
pray. So.
No, absolutely. And also spiritual discernment. Be
Yeah.
careful because it's not everybody who walk with you and laugh with you and talk with you are your friends and they mean you're good. So test the waters, test the spirit to hear.
Yes, sir.
And for those of you who have to come in late, you know, want to no, I used to no, have no cell phone and each up off on the ears and I have big laugh and chat and when I listen to music. And when I put that phone in the bottom of the bag and put it on ticklish, make it tremble when it a ring. When it don't tremble and you reach inside, then you can untrimble it. The man and worse is yet to come, because the man them don't have no money. Yeah, right. Those who have ears to hear, let him hear. It's not by chance that I'm speaking to you guys about a matter of this nature. It's not by chance. I don't call it chance. I don't call it book up. So, I beg you no, want to take it easy, want to be safe. And once you do that, one should be good to go. All right. So now we are on to, we started, wait name again, now remind me. Stationary point, don't talk to me, no? Habla me.
Yes, sir.
No, I'm just saying, talk to me. What with the stationary points, don't?
Stationary point. I think so.
Yeah,
I
I
believe.
Yes,
think so. That's
I
the
was.
last thing we looked at.
Yes,
Stationary
sir. That's what we
points.
did last class.
Yeah, man, stationary point. No, what much I can tell you, having been in the betting session today, my idea was concretized. It's a topic you're made upon you know. Me telling you straight up. It is a must-have on the exam paper. It is a staple. And based on conversations I had with other people today, It a go dead. Don't ask me what question is going to be there because I don't know. Oh crap! For crying out loud, I don't want this version. Oh Lord, sweet Jesus, help me. Um, don't ask me don't ask me what question will be there. What I can tell you, the it is on the paper. It is on the paper, and I really want you guys to appreciate it. All right, guess what is happening to me now? I'm finding the stationary point, but I'm finding on the word copy, and the word copy. Oh, the devil's a liar. The word copy will not be sufficient. But anyhow, we have like about an hour something. Let us see if we can just work with it. I'm almost sure that I had sent the other copy to the thing, but never mind. Share screen. Oh God, I feel tired. Jeez. And then I'm going to be sharing this document. Let's hope. All right. So some of the things are not coming out so clear on it. But in the interest of time, let us go.
Which
Okay,
one are
right.
you sharing now?
Say it again.
What you sharing on?
Oh, my tablet. And I kind of figure out, I'm not one who gets defeated very easily. So I kind of figure out that little thingy bobby. It wanted to defeat me, but the only problem though is that when it is on, I cannot scroll. So I have to stop. I have to stop it in order to scroll, but that's fine. All right. So I'm almost sure that I introduced you to Desmos graph. Did I?
Yes, but I
Yes,
don't
sir.
remember.
You don't remember? That's fine. Okay. So the question that we looked at, I think this was a graph that is on screen now. That was a graph that we plotted, right?
Yes, sir.
All right. So this is what I want you to do for me today, and I'm gonna work you through the stuff. And hear me
I
out.
can't see a thing when I find it.
So you can bigify.
Come on. Tell me if the bigify one you're working better, little betterish.
Way better.
Yes, sir.
All right. Thank you. All right. And yes or no, Sash, you can take off the glasses here. I'm sure you can see this from a distance. All right, let's go. I am going to spend, if I'm going to spend an hour on this question. I won't tell you why I'm spending so much time on this. Because when I finish this question, I'm supposed to understand this. And hear me out again. The question here, I could come, not the exact question, that something here, depend on the final exam. When I go get 3 questions, or and incidentally, I got a communication. Let me just tell you for now, because Pastor Christine picked me first. So me have the information, I'm sharing it with you guys first. I got word today that the final exam for math, I don't know about the other courses for math, will be online. All right. Here what is going to happen to you guys. Is it just like how we did it for the mid semester? It's the same way we're going to do it for the final exam. Your cameras will need to be on for the duration of the 3 hours. And I want you to understand what is happening here. Unless otherwise instructed, um, we have to put some things in place because of some things that we're seeing taking place. All right. I know you guys are good, but just to let you know, say, what is what. And again, I'm going to say to you, don't blink because you must understand this. We have one more class before this leg of the semester is ended or comes to an end. You must understand this piece now. On Thursday, God's willing, I want to introduce to you. I made L'Hopital's rule on Thursday. Yes, I'm going to do L'Hopital's rule on Thursday. Just get that out of the way. I can use about half an hour to do L'Hopital's. Get that out of the way. And after L'Hopital's, I'm going to do some first order differential equation that I know I can start and finish. Right? I am so I want boy, I want your undivided. And here goes. Here goes. Matter of fact, I won't even ask you to do the question on your own. I'm going to project what it is, and then we'll work through it. Then I give you the questions. Then you can master it. Let me say it one final diggy time. When I mark those papers, every one of them must pass the course or else. And it's a threat. This topic, every exam paper you take up, there is a question on this topic. It is a must-have. Matter of fact, I said I'm going to use an hour to do this. I'm going to use half of an hour to go through this. And when I do the half an hour to go through it, then I'm going to ask you to find in a past paper one of these questions, and we're going to work it. Let's go. And given that the function y is equal to 2x cubed plus 3x squared minus 12x minus 7, evaluate 1, the coordinates of the y-intercept, the critical points, determine if the critical points is or are minimum or maximum, determine the point of inflection, sketch the graph of y showing all the points. Relatively easy. Relatively easy. For the purposes of tonight's class, I will accept you just looking at the at Desmos on Thursday. All being well, I could show you the sketch, because I mean, remember, I have some other sketches to show. But the coordinates of the y-intercept. Does anybody remember how we find the y-intercept? The y-intercept is found when? The y-intercept is found when?
When x is equal to 0, sir?
Every single time. Very good. Every single time. The y-intercept is found when x is equal to 0, and the x-intercept is found when y is equal to 0. Very good. Give me another name for critical point.
Turning point.
And another name. It's a stationary point.
S1, yes, sir.
Stationary, right. No, why am I making reference to it? Sir, use critical point because critical point sounds big school, and Calculus 2 don't speak of turning points and stationary points. Calculus 2 speaks of critical point. So I'm actually trying to make a connection for you for critical point from now. But if you go into the exam and see them ask about stationary point, don't say, Jesus be sir, never teach you this. Are the same something. And if you go into the exam and see them and them talk about turning point, not get nervous. Are the same thing. So critical point, stationary point, turning point, it means the same thing. It means the same thing. All right. So we need to determine the critical points. Now, there are several things that we do for critical points. There are several things to do for critical points. To find critical points, you know how to find the y-intercept to put x equals 0. For critical point, we are going to be differentiating the function. That's the first step. Once we differentiate the function, we're going to set the differential equals to 0 and then solve for the value of x or the values of x. The value or values of x there will be the critical value or the critical values. You're going to substitute that critical value or those critical values into the original function that will result in the other part of the critical value, the other point, your y values. Together, they form a point, because a point is a combination of an x value and a y value. So that's how you'll find the critical point. To determine the stationary point, same thing as critical point, we differentiate the function f of x, set the differential equals to 0, then solve for the unknown. This gives the critical values. Substitute the critical values into the original function. Then you're going to, the results will be the stationary point, critical point, or turning point, and will be written in the form x comma y. My Microsoft Word document is not showing you my parentheses, but don't worry about it, right? That's how we find the critical point. How many steps? 4 steps. And to determine the nature of the critical point, I have 2 methods. And we're going to go through those methods now. All right. So that's what we do for that one. All right, good. Any questions so far? Any questions so far? All right, great. I'm as clear as mud. So let's go. And then now it is asked me to do the point of inflection. I did tell you what the point of inflection is. Looking at it, doing an investigation of the graph, the point of inflection is really the midpoint between the critical points. The point of inflection is really the midpoint of the critical points. Midpoint speaks about halfway. So it is exactly halfway between the turning points, the maximum value and the minimum value. All right, maximum value and the minimum value. And then we're going to be sketching the graph. No, the sketch of the graph cannot start at the top. It has to start at the bottom, because all the points that we would have gotten must be reflected on the graph. So my critical points must be on the graph. The point of inflection must be on the graph. The y-intercept supposed to be on the graph. Determine if it's a maximum or minimum. I have to indicate whether or not it's a maximum and indicate all of that on the graph. Yeah, so 4 set of something supposed to be on this graph. Showing all points, everything must be on the graph. Okay, let's go. Intercept. X equals 0. It says y-intercept, you put in x equals 0. Look at my function. My function is y equals all of that. Anywhere in the function I see x, I put 0. Watch it. Don't worry about not seeing the parentheses. Here, the parentheses are there. I don't know why it is not showing here. So what parentheses are there? All right. So what I have is 2 times 0 cubed plus 3 times 0 squared minus 12 times 0 minus 7. The first 3 terms go to 0 because 0 times anything is 0. So all I'm going to be left with is -7. So my coordinate, if x is 0 and my y is going to be -7. So what I'm going to be having is 0, -7. And that is my y-intercept. I want you to look at that for me and tell me if you understand. If you have a challenge with that, let me know, please and thanks. Are we okay?
So you said for x, all x would be 0. Could you go back a bit, sorry?
No problem, Oshono. That's fine.
Yes, sir. Yes, sir. Thanks, sir. I just wasn't understanding the first part.
Still don't understand it?
Yes, sir.
You see it now?
Yes, sir.
All right. You know, I think I have OCD, and feeling very uncomfortable that my parenthesis is not coming out. So while I'm responding to you, if I sound distracted, it's because I'm trying to convert the document to a PDF, as I normally do, so that I can.
Yes, sir.
Yes, please.
Coordinates of y-intercept. They'll give you a question like that. So if they say y-intercept, everything in the equation that had x on it must be equal to 0.
Yes. Yes.
And if they say
x-intercept, you'll put y equals 0, and
everything
then
in the Go again?
You're gonna put y equals 0 and then solve. But let me just thank you for answering that, asking that question. I'm thinking. I don't think they will ask you to find the x-intercept to put y equals 0. I'm going to tell you why. Unless a function is easily factorizable. Because I can't recall from the courses that you would have done at the associate degree level where they will teach you polynomial functions, how to like polynomial division. I can't recall if you guys would have done it. And for sure, it is not on your syllabus here for me to teach it. I may not teach it. I may not teach it. I may not have the time.
So basically, sir,
Go ahead.
they would always say y-intercept.
That's what I'm thinking. Yes, honey bunches. So I said that to you to say to you that they will ask you for the y-intercept. Yes, honey. Any other question? All right. So forgive me. I'm going to. Have I stopped sharing?
Yes, sir.
All right. This is bothering my spirit. It's bothering my spirit. So let me just.
So you're going outside again?
I miss him lounging again, man. I mean, you want to say it, but this, I hate them yang noisy or something. Them can't buy a good Kawasaki. I don't make no noise. Yeah, man. I really feel
somebody
beat up.
told me something like a while ago. I better them make nice than them silent, because at least you know so them coming behind you.
Talk truth. Talk truth. Well, I tell them, man, me not think Jesus please it all the man them are going wicked. All right, then they must yes, this is how we like it. This is how we like it. It is showing much better now. Hey, God good enough. Hey, him sit down so high and make up online. And I can stay with me there. And a teacher now. And a teacher now. No, Jesus, is that it? No, this is a Word document. Oh, stupid. Stop share. Where's the document? I just had it. Oh, okay. So that's the one. So the one with the Microsoft Cloud. Okay. So start sharing again. Share screen, and it's the one with the Microsoft Cloud. Right, that's the one. All right. So it's much better for me now. I'm seeing my parentheses now. Great. Yes. So I'm saying to you, because if this were business calculus, I would have taught my pre-calculus students polynomial division. So if this were business calculus, I would say to you that they could ask you, but because I don't think you guys did it, I don't think they're going to ask you to find the x-intercept gradient y equals 0. But if they do, it is going to be a function that is easily factorizable. But I don't expect them to do it. All right. But if they do, it's going to be easily factorizable. And if they do, that part of the question can't come for more than 2 or 3 marks. All right. All right. So let's go now. So for my critical point, so we've done that. So it's going to be 0, -7. For my critical points now, it's going to be my function. I am differentiating the function. So y is equal to that function, 2x cubed plus 3x minus 12 minus 7. I'm differentiating that function. 2 times 3, 6. I'm going to get 6x squared 2 times 3, 6 again. I'm going to get 6x minus 2. Mm-hmm. Mm-hmm. All right. Yes, I know the battery's dying, but you're good. All right. And then what is going to happen is what is going to happen is um what is going to happen is I'm going to have 6x squared plus 6x minus 12. Remember, for critical points, dy by dx is equal to 0. For critical points, dy by dx is equal to 0. For critical points, dy by dx is equal to 0 every single time. So I'm going to set my 6x squared plus 6x minus 12 to be equal to 0. And I recognize that 6 is a factor throughout the equation. So I'm going to divide the equation through by 6. So 6x squared over 6 is going to be x squared. 6x over 6 is going to be just x. Negative 12 over 6 is going to be negative 2. And 0 over 6 is going to be 0. So we are doing this division to make the function easier to factorize. We're doing this division to make the function easier to factorize. To make the function easier to factorize. All right? Recall, to factorize a trinomial above, we multiply the coefficient of x squared, which is the number in front of x squared, by the constant. Are you understanding this first line up here? Do I need to go through this line again? Go ahead.
Sir, kind of.
Yes, sir. Go back to it.
So I have y is equal to 2x cubed plus 3x squared minus 12 minus 7. That's my function. That's the function that I have. I'm trying to find the critical point. Sorry, I'm trying to find the stationary point. I'm very sorry. I'm trying to find the turning point. I have to find the first derivative. So I'm going to find dy by dx. I'm going to find dy by dx. So when I differentiate the function, 3 times 2 is going to be 6. Remember, when I differentiate, I reduce the power by 1. So this becomes 6x squared. Becomes 6x squared. Oh, the devil is a liar. I still see my screen?
Yes, sir.
All right, good. Oh, come on. Sorry, I'm trying to annotate and it is. All right, forgive me. Let's try this again. All right. So what I'm saying to you is that's my function. That is my original function. When I find dy by dx, that's what I get. You know how to differentiate. We've spent most of the semester differentiating. First principles, quotient rule, product rule. You know how to do it. All right. And then what I'm going to be doing for critical points, dy by dx is equal to 0 every single time. In order for me to find my critical points, I must set dy by dx to be equal to 0 every single time. All right. And then when that is done, in this case, I'm dividing through by 6 because 6 is a common thing. Sir, we can always get a chance to divide through by 6? No. But we recognize this one to be divisible by 6. I'm going to do that. And I'm doing this because it makes the division, it makes the function easier to factorize. Now, when I do that, I'm left with x squared plus x minus 2. I'm left with x squared plus x minus 2. All right? And
Sir,
mhm.
so when you do the 6x squared, sir, the main objective is to get the x squared part to be equal to 1x squared.
No. When I get the 6x squared part, the main part of that is to factorize a function. I'm going for the charger. It's to factorize a function. Can you look at it one more time, please, in the meantime? Let me just run for the charger. My data pack and then come back, please. 1 minute. Oy. All right. So, Krishna, I know you were asking the question before. I went inside. Look at it and tell me if it's a little clearer to you. If not, allow me to go ahead and do some more further explanation.
Yes, sir. It's clearer.
It's clearer. Okay, good. Are there any other questions coming from anybody else?
Sir,
Mm-hmm.
for that line, will you always be able to factorize?
Yes, you must be able to factorize because that's the only way you're going to be finding the other value in order to get the stationary points. So you'll be able to factorize. The function that is given should be factorizable. Yes.
So just to confirm, is basically the HCF you use to divide it out on that line, right?
Which HCF we're talking about?
No, where you say divide by 6.
Yeah, it's a High School factor that I'm using. Yeah,
Oh,
but
all
yeah,
right.
but remember no remember that sometimes you won't be able to factorize. Sometimes you won't be able to factorize the or divide through by number. All right, let me just qualify what I mean by sometimes you won't be able to factorize. So is what I have divided through by 6. Some other functions. Okay, let me just stop doing that and just show you another example where okay, and there is no other example in this document. But there are other examples where um, I'm unable to divide through by 6, as you see I would have done there. So sometimes you may get when you do your integration, your differentiation, you may end up with something like x squared plus 7x plus 12. You can't divide through by anything. You just have to go factorize a function as it is. In this here case, what we're getting is 6x squared minus 6x plus 6x minus 12. In that case, that's what we're getting. 6x squared plus 6x minus 12. And I recognize that after doing that, I'm able to do all of that. 1 minute, please. All right. So you understand what I'm saying, Krishna? Hello, Krishna? Kelvita, you understand what I was saying, just trying to say to him?
Yes, sir.
Because you asked a question if the function will always be able to be factorized.
But
And I said to you,
what I want is what Lester asked is what I was supposed to ask.
okay, all right,
That
all
line
right.
will always be there. Will always be something there to divide it out.
No, no, no. So Lester, you understand what I'm saying to you that you'll not like what I'm able to divide through by 6, you will not be able to always divide through by a number there. And guess what? I didn't even have to divide through by 6. I could go ahead and factorize the function as it is. But it's just going to be a bigger function to factorize. So we have to multiply the coefficient of x squared, which is 6, by the constant, which is negative 12, and 6 times negative 12 is going to be negative 72. You're going to need two numbers and multiply together will give you negative 72, but when added will give you positive 6. We don't have time for that. Not at all. We divide through by 6. And then now end up with x squared plus x minus 2. And when we end up with the x squared plus x minus 2 now, then we can say, you know what? Multiply the coefficient of x squared, which is 1, that is in pink there, by the constant, which is negative 2. And when we do that, I will say to you that I have negative 2. Easy to work with. You remember say, I need two numbers. When multiply together will give me negative 2, yeah. But when added, will give me the middle number, which is positive 1. So the factors of 2 are only 2 and 1. So which one will be positive, which one will be negative? We want a plus 1. That means that the bigger number is supposed to be positive. So I'm going to have x, the 2x to be positive, and the x to be negative, and the x to be negative. And that's how I'm going to do my factorization. All right? Hold on a minute, please. Hello? Hello? Oh, you're outside? All right. Hold on. Somebody is here to me. Just give me half a second. Forgive me. Hold on, please. All right, sorry about that. Um, so what I'm saying to you now is we are going to be multiplying the coefficient of x squared by the constant. So it's going to be that one that you have in pink multiplied by the -2. I need two numbers. When multiplied together, will give me -2, but when added will give me the middle number in blue, which is going to be +1. Only two factors you have of 2, 2 and 1. But I want a +1. So it suggests to me then that the 2 has to be the positive number. Had that been -1, it would suggest to me that the -1, that the 2 would be the negative value. All right. And then now, that line is just explaining what I just explained, so I won't do that again. So this is what I'm doing now. I'm saying +2x minus x. So where did we get that from? Those are the factors. Remember, I did say to you that the factors are +2 and -1. Factors are +2 and -1 because I want a +1 in the middle right there. So I'm putting that in, and then I'm going to be grouping. Now, you may say to me, sir, why did we have to do that step? We had to do that step because we're factorizing by grouping, and we can't group three things because one of the groups will have 1 and the other group will have 2. So we want a group where we have each set of parentheses with an equal number of items or terms. All right. So when I replace my +1 with 2x and -1, now I'm able to group the first two in the parentheses, leave out the second two every single time. Notice right there, I have x squared plus 2x minus x minus 2 equals 0. Now, when I group, I'm putting the first two in brackets. Then, sir, what if me to put the -x first and then the 2x after? Not a problem. Anything you write first, just put the 2 first, something in the bracket. Always leave the middle sign outside every single time. Always leave your middle sign out every single. So wait for the middle sign. The middle sign is that sign. When you write the first two terms, you will have a sign that is going to separate the first two terms from the second two terms. You're going to have a sign that marks the first two terms from the second two terms. All right? And then again, put the other thing in the parentheses. Now, I need to tell a little story here. So, story time. You see, anytime you have a negative sign in the middle, respect it. It is called Mr. Negative because I want you to recognize something here. You recognize that that 2 there is a -2. Do you recognize that that 2 is negative? Yes or no?
Yes, sir.
Yes,
Yes,
sir.
sir.
What do you recognize with that 2 right there, so no?
Comes up plus,
Positive.
positive.
And becomes a positive, Andrew, because of that negative sign that you factor out right there. So it's
Correct,
very
sir.
important, very, very important. And that's the essence of the story. The story is whenever you have a middle sign that is negative, you have to flip the last sign in the parentheses. Besides, whatsoever sign that is here in the parentheses has to be the same sign that is there. I can't have that sign there to be positive and then that sign to be negative. If that
Because
sign
a
is
negative
positive,
time, sir, because a negative times a negative will give you
a
a
positive.
positive, right?
Very good.
And a negative times a positive will give you a negative.
Negative. Very good. All right. So that is the essence of my story, and I'm going to stick to it. That's the essence of the story, and I'm going to stick to it. All right. So you have to bear that in mind. It's going to be very important. No, you're going to ask yourself the question: what is common here between this x squared that is common to the 2? What is common between x squared and 2x? And your answer would be
X.
And that's why I factor out the x. Very good. So it's going to be x. So I'm going to be factoring out the x. So then I'll ask myself, what is left? Then I will say x is left, sir, because when I multiply x by x, I will get x squared. I'm going to factor out the x from the 2x. I'm going to have 2 left. So I would have factorized my x squared plus 2x into x times x plus 2. Watch this now. What is common between x and 2 on this side? What is common between x and 2 on that side? See, I highlighted there. What is common between x and 2 on that side? Talk to me.
1.
Excellent. Every single time. 1. Numero uno. Every single time. So I'm factoring out my 1, and that's why I have a negative 1 here now. Look at it. That's why I have a negative 1 there. And that negative 1 is going to be factored as my multiple there. And what is going to be left is x plus 2. Do you recognize now that the same thing in that bracket is the same thing in that bracket there?
Yes, sir.
Yes, sir.
Good. So I can now factor out my x plus 2, which is what I did right here. So now that I factored out my x plus 2, what I'm going to be left with is going to be x plus 2. When I take off the x plus 2 right there, when I cross out that x plus 2 in the parentheses, you recognize that it's only that x outside that is left?
Yes, sir.
And it's that x right here. So I'm going to cross it out from here, so 2. You recognize that is the minus 1 that is left? See the minus 1 inside here. So that's how we factorize our stuff. That's how we factorize our stuff. All right? Now, that's how we factorize our stuff. So I'm going to say to you now, either x plus 2 is equal to 0, the first one here, I write down here so, and if that is equal to 0, that means x is equal to negative 2. It means that x is equal to negative 2. And if this x plus 1, this x plus 1 here, this x plus 1 is equal to 0, it means x is going to be equals to 1. So I now have 2 values of x. One where x is going to be equals to negative 2, or when x is going to be equals to positive 1. Negative 2 and x is equals to positive 1. Any questions so far before I move on? Remember, you need to overstand this. You can't
Sir.
wait until, yeah.
So in the grouping part, the second line, both of them must always, the x plus 2, both of them must always be the same in the bracket?
Yeah, every single time, because if they're not the same, you're not going to be able to factor it out.
Okay.
Sir, I have a stupid question.
No question is stupid. Go ahead.
So, if that middle number, what am I put it now? Sir, go up, Pickle. Stop. So you have x squared plus 1 minus 2. Let's say when you multiply the 1 minus the 2, but you can't get that middle x there. Yeah, when you get the brain, I think right, I don't know, put another question in my ask.
You're saying that your question is, if I can preempt you, is if you'll be able to always find the factors right there.
Yes.
Yeah, man. You're always able to find the factors. Trust me. We're not going to give you a question that is not going to be factorizable. It defeats the purpose. We're not going to give you a question that you can't factorize. I promise you. And if them give you a question we can't factorize, remember me, I'll go to the mark. Real talk. But you can't factorize.
Okay, sir.
No, man. So you don't have to worry about that part. Alrighty then. Recall. These are known as my critical values. They are known as my critical values, not my critical points, because a point consists of an x and y value, coordinate, an x and y value. I don't have an x and y value yet. I just have my x values. So I now need to find out the corresponding y value in order to have my xy value to give me my point or my coordinate. Remember, a point is a combination of my x coordinate along with my y coordinate. Very important. Extremely important.
Even sir,
Oh, you just a come.
yeah.
All right, you will catch up. All right, now. So we need to substitute these into the original function. Now remember, it has to be the original function that you are substituting into. You cannot substitute it into any other function but the original function. You cannot substitute it into any other function but the original function. You must substitute into the original function. Into the original function. You must substitute into the original function. Let's go. So x is equal to -2. So I'm going to put x equals -2 into my function. So what I'm going to have and so my original function is 2. So the original function up here, so 2x cubed plus 3x squared minus 12x minus 7. See it right here, so 2x cubed plus 3x squared plus 12x minus 7. Hit that. Anywhere in that function I see x, I'm going to put -2. Anywhere in that function I see x, I'm going to put -2. Anywhere in that function I see x, I'm going to put -2. Anywhere in the function I see x, I'm going to put -2. So 2 times -2 cubed plus 3 times -2 squares minus 12 times -2 minus 7. And then that is going to be equals to -2 cubes is going to be equals to -8. So I'm going to have 2 times -8. And of course, -2 squares is going to be equals to +4. So it's going to be plus 3 times 4 minus 12 times -2 minus 7. Then I move into my other line. 2 times -8 is going to be -16. And 3 times 4 is 12. And -12 times -2 is +24. And you told us just know that when we multiply two negative numbers, we get a positive number. But when we multiply a positive number by a negative number, or a negative number by a positive number, the result is going to be negative. But he correctly stated, sir, when you're multiplying two negative numbers, you get a positive number. And of course, we have my -7. Now, -16 plus 12 is going to be -4. -4 plus 24 is going to be +20. And +20 minus 7 is going to be +13. So y is going to be equal to 13. So my coordinate, my critical point is going to be when x is equal to 2, y is equal to 13. So it's going to be when x equals -2, sorry, y equals 13. So my critical point is going to be -2, 13. -2, 13. That's my critical point. One of. How many critical points will I have? 2. How you know that, sir? Because I have 2 critical values. Then, sir, how you know you can get 2 critical values? I know I was going to get 2 critical values because of this. It says x squared plus x minus 2. Whenever you're factorizing a polynomial, the highest power in the polynomial tells you how many solutions it has. Real or imaginary. So the highest power in this one is to the second squares. So it suggests that we're going to have two different answers. Two different answers. And incidentally, the answers don't have to be different. You can have two same answers. But the point I'm making is that you're going to have two answers. It could be two different answers, or it could be two same answers. All right? Could be two different answers, or it's two same answers. Two same answers when the functions are perfect squares. All right? Now, let's continue. And then, those are known, recall, those are known as my critical values, good. And then I'm going to do the same thing. I'm going to put x equal 1 into the function. I'm putting x equal 1 into the original function. X equal 1 into the original function. Anywhere in the original function I see x, I'm going to put 1. Anywhere in the original function I see x, I'm going to put 1. Anywhere I see x, I'm going to put 1. Remember the original function, 2x cubed plus 3x squared minus 12x minus 7. So anywhere in that original function I see x, I'm going to put 1. So it becomes 2 times 1 cubed plus 3 times 1 squares minus 12 times 1 minus 7. 1 cubed is equals to 1 times 2 is 2. 1 squares is equals to 1 times 3 is 3. And negative 12 times positive 1 is going to be negative 12. And my negative 7 is my constant. I write it back. Then I'm going to have 2 plus 3 is 5. 5 minus 12. Careful now. 5 minus 12 is going to be negative 8. And negative 8 minus 7 is going to be negative, nope. 7 and 5, 12. 5 minus 12 is 7, negative 7. And negative 7 minus 7 is going to be negative 14. And that's how I get my y value to be negative 14. So what I'm going to have is 1 comma negative 14. So I have my critical points. So I have two critical points. One where it's going to be negative 2 comma 13, and the other is going to be 1 comma negative 14. Now, what is important, guys? What is important is the fact that you must now be able to say the 2 comma negative, the negative 2 comma 13, is that a maximum value or minimum value? So why does that become important? You need to know how the graph turns. Does the graph turn up or does the graph turn down? All right. So you need to be able to say that. And that's how we classify the nature of the critical points, turning points, stationary points. So the next setting you see the nature of the turning points, critical points, or stationary points. Now, there are two methods. I did one method with you before, and now I'm looking at the graphical method. The method that I did first was, if I can recall, the method I did it first was to find the second derivative, I think. Yes. So that's a part 3 here. That method, what I did with you was to find the second derivative. And the second derivative is differentiating the first derivative one more time to get the second derivative. So we did that second derivative differentiation with you. And then we substituted our value or coordinates. But in this case, of course, we recognize it's a whole number. But and then we just work with the corresponding value. In this case, I'm going to show you now another method. So there are two methods. And incidentally, I did say to you last class, critical points, that there are two methods in doing the critical points. Method 1 is to differentiate the function and then differentiate it a second time. And then method 2 now is to see the graphical method in example 2. I am now in example 2 and I'm using the graphical method, right? So you can choose which of the two methods you want. My personal preference is the graphical method. I know some students don't like the graphs. It doesn't matter really. You can go ahead and use the second derivative method. It really doesn't matter to me. If you want to do the second derivative method, go ahead. Every time I mark papers, some students use one method, another set of students use the other method. And, varying the method that they use, it amounts to their strength, and never have a concern about what happens thereafter. All right, let's go. We are on the mend. So, what we're doing here now is to, all right, so when x is equal to -2, I'm investigating what happens. So when x is equal to -2, look at what happened. I'm looking at the left-hand side, and I'm looking at the right-hand side. Oh, sir, this look like when you do limits, don't? Same concept. And that's why I prefer this method. You know why? Because it connects things that we would have done. It would have connected things that would have done before. You would have connected things that would have done before. So it says, please note, to investigate the nature of the stationary points, we will use the first differential and not the original function, right? So what it is that we're investigating the turning points. Is the nature of the turning points we're investigating, the nature of the turning points we are investigating. What is a turning point, sir? It's going to be the differential that we are investigating, not the original function. Not the original function this time. It is a turning point. F dash of x, or dy by dx, is what it is that we are looking at. We are not interested into the original function at this point in time. No, we are interested in the slope, in dy by dx, in f dash of x. All right. So let us look at the left-hand side of the function. And I think I'm going to need my spotlight here. So let me just go ahead and do it. Let us look at the left side of the function. So this is a function that we're interested in, dy by dx, my differential. My differential is what it is that I'm using to investigate, not the original. Go ahead, Kels.
Stop right there. Just for the purpose of those who don't know, that -2, where you get it from?
The -2 is one of the critical points.
Okay.
-2 is one of the critical points. So is +1, I believe the other one is. Those are the critical points. All right. So that's what it is that I have the -2, and I'm going to be investigating the -2. Hold on, please. All right. So what we're going to have now, we're going to be investigating the -2. We need to look at the left of -2. We know that if it is equal to 2, it's going to be 0. And we need to look at the right of -2. Sir, how you know that it's going to be equal to 0 at that equal point? Because we just work it out. And we know say it's equal to -2. So we're going to look at the left of it and the right of it. So let us look at the left of it. The left of it is we're investigating the turning point. I cannot overemphasize this at this stage. What we're investigating is a turning point. So when x is less than -2, let us find a number that is less than -2. Can you give me a number less than -2?
-3.
-3. Thank you very much. I was hoping that somebody would have said -1, because I would have slapped you silly. Because remember, -1 is a bigger number than -2. So very good. -3 is less than -2. So -3. Anywhere in that function, I'm going to put -3 and see if I get a positive or a negative value. So -3 squares is going to be 9. And 9 times 6 is 54. Hold that. And 6 times -3 is -18. So 54 minus 18 is how much? What is 54 minus 18?
36.
All right, and what is 36 minus 12? 24, don't?
Yes,
Yes,
sir.
sir.
See here? And that's why I put it as positive. You know, I'm not interested in the 24. I'm only interested in the color of the 24. What do I mean by color, sir? Is it positive or negative? I'm not interested in the 24. Don't mean a thing to me. What matters is that it is a positive 24. So I know that that is positive. And again, if you put it equals to 0, you're going to, if you put it equals to -2, you're going to get the function working out to be equals to 0, as I showed you there. All right. And then no, let us use an
Put trend downward, sir.
Say it again.
Do it trend downward?
When I say downwards, what do you mean, hon?
The curve or critical point?
Oh yeah, yes, son. And then now when you look at the right hand side, a number that is greater than -2, maybe you can call it 0. Maybe you can call it 0. I'm working smart, not hard. So I'm going to call it 0. So, and guess what? If you work with any number that is greater than -2, you'll get the same result as I got on paper here. So I'm going to say 6 times 0 squared plus 6 times 0 plus 12. I'm going to get a -12. You notice I'm not interested in the -12 now. I want to write it there because I want to show you what it is. I am not interested in the -12. You know what I'm interested in? The negative sign alone. And the negative sign says negative. So come and get this. So watch this now. It's when you go up here, so you're climbing a hill, it is positive. Yeah, step up in a life, Sash. Yeah, man, positive. And then when you reach right here, so you are on a plateau, you are on a ridge, you can't go anywhere. You're not increasing, neither you're decreasing, you're constant.
Negative.
That's where the 0 is. And I want you to know -12 is when you come off of the hill. So Sash, I keep up the summer body, and we should go up at the hill and she tell Charlene, say, oh, watch this, Charles, me fitter than you. But when Sasha come down, Sasha blow hard because she's coming down the hill. So look at what is happening. You notice my trajectory is going up, stationary, then down. Tell me if this looks like an N. Can you look at it? Look at the red something. Can you see it looks like an N? Talk to me.
Like a what, sir?
Like an N, like in Nancy.
Sir,
Watch
I'm
it
not
again.
the end this, sir.
No, it's easy though.
All right, watch it. You see where the spotlight is?
Yes, sir.
Watch it. You see it look like a N? Okay, do you see that it curves down?
It curves down, sir. But you say that.
Okay, it curves down then. It curves down.
Input they look like they kick it to it.
All right, then do me a favor now. Write one N, not the sexy one. Just write one N, one big N. Not the capital N, we write it like a stick. Write the upside down view. That's what it is. So that N, I normally say that is negative because when it's negative, it's going to be a local maximum. So see here is a local maximum. Why? Because the shape of the sketch of the graph looks like an N for negative.
Question, sir. Where the -3 comes from?
-3? Which -3?
In the positive side bracket. The left hand side.
Oh, right here, sir? I need
Yeah.
to choose a number that is less than -2. And Charlene told me -3.
Oh, so
Charlene told me -3.
you just go one less of the point, the x value?
Guess what? Even they put -4, but I still get a positive value. Even put -5, but I still get a positive value.
Doesn't matter?
It doesn't matter. It doesn't matter at all. Not one iota of it.
As long as you get a
remember,
positive, right, sir?
as long as you put a number that is bigger than the one there, that is smaller than that one because it says x is less than -2. As long as you put a number that is smaller, and when you evaluate it, whatever sign that comes out, the sign can be either positive or negative. But you have to make sure that you do the calculation right because you can't have a turning point where two of them are going in the same direction because they cannot turn. If the car is going in the same direction, it can't have a turning point because it cannot turn around. It makes sense?
Steering not working.
Steering don't work. You better come out of that and drive a Hunkyat.
Sir, what is a local maximum?
It's a local maximum is, this is what I'm saying to you. So the graph turns downwards. So when the local maximum, the graph turns downwards. Let us look at the graph. Let me jump ship. Okay. Let me look at the graph and show you here. It's a local maximum because that's my maximum point. That's what it is that we're saying. That is the maximum point on the graph. That's
Sir,
a
this
maximum
look
point
like
of the
the
graph.
end now, sir.
Which is the point I'm saying. No, don't look at this side over here now. Let me show you the N. The N is this, what I'm talking about here. That's the N I was talking about. This is the n I'm talking about. When I say n, this is negative n. So this is n, and if I want, I can put EGATIVE, right? So this is n for negative. So when you see graph turn down, so look like one n is a negative graph. When you see the graph turn down, so look like one n, it's spelled NEGATIVE, is a negative graph. When you see a graph look like one U, don't ask me, oh, you're positive, right? When you see the U, you're positive. So this piece here is a positive graph because it shapes into a U. So I would say that this has a local minimum. See here, down here says a minimum point on the graph, the lookless point on the graph. So when we speak of maximum and minimum, this is my shape of this curve, That's my sector graph. And my sector graph is telling me where is the maximum point on the graph? Up here, so sir. Where's the minimum point on the graph? Down here, so sir. Right? So this is just one application of how we use our differentiation. This is one application on how we use our differentiation. All right. So I have my local maximum. I have my local minimum. I have my local max. I have my local min. Any question? I know it's been 7 o'clock. Any questions?
Sir,
Yeah.
just want to get the 1-2 step out in my head.
Mhm.
Up top, it would be 4 step.
Where? Here, so?
Up is up from the
Up with
beginning,
who?
right?
When it's a four
How
steps
the
start.
question start? That you
Question
were
start.
working on the -3 and the -2.
Interesting.
Yeah. So it would be one. Yeah, differentiate.
Gosh,
Then,
that's part three of the full question.
huh?
That's part three of the full question.
All right, no bother, sir.
Right. Thanks, skills. That's part of the question. Did I send this document to you already?
Piece of it, sir.
Did I send this one in particular? That's what I'm asking.
I'm not sure, sir.
Okay. All right. So I'm going to send this exact one to you as soon as class ends because I want you to look at it. I'm not worried about you. You don't need to worry about it. You will be able to. You'll be fine. You'll be fine. All right. What I'm going to do, I'm going to end here. I understand how difficult a Tuesday class is because people are still trying to commute, and especially knowing Christmas, you have a lot more traffic on the road. All
Traffic
right.
turned up.
Yeah, man. I know. And trust me, the teacher was feeling very drained, and I was going to go in and go get a little lay down and then go finish my duties that I had to perform today. All right. So Thursday coming is going to be our last class for this leg of the semester. Last class for this leg of the semester. Um, I would just say to you that you guys have done pretty well. We have covered quite a bit of the information. When I say quite a bit, we covered enough something already. I literally have 1.5 topics left with you. I will finish off this topic, this stationary point on Thursday, and then I'll do the applications of integration, which, trust me, 90% of it I've already done. I'm only going to show you one little piece with a graph, and then that can take like 20 minutes because I don't know if we integrate, because we just finished integration. All right. Um, so I'm going to finish off this area, and then hopefully, if time permits, I can do L'Hopital's rule. If it doesn't permit, not a problem. It means that I just have one full topic to do when we resume in January, God's willing, and I should be able to finish those 3 topics. I mean, the one topic with about 3 things inside of that one unit that is left. L'Hopital's first order differential equation and something else I don't quite remember. But for the most part, you guys have done well. Some of you know you need to work a little harder than others because of the grade that you got. Let me tell you something before my final thought. Some of you did very well on the mid-semester. I raised the issue in the exam, in an exit meeting the other day about, we call it about registration. I'll give you an update on that. If I don't hear anything else from them, best believe I'm going to distribute those papers to you, because I really want you to look at those papers. And I said to them, I don't know how much longer I can hold out. They need to come back and say something, give me a position. I'm going to also ask you, impress upon you students to sort out your registration. The institution needs the money to pay staff and need the money to pay utilities and need money to pay them Zoom
Sir,
license and etc. etc.
sir,
So those of you who owe, please pay up. Yes, please.
sir, if that's the case, why they make it so difficult to pay?
Oh, you're trying to pay online. I can't pay online.
Yes, sir. Them say me have to do it via Paymaster and the line long.
True. What about you try Scotiabank and it don't work?
Scotiabank?
Yeah.
Put the money on the card and pay it at school.
Yeah,
Or
that's
put the money.
Yeah, you can pay through
go to
Scotia
school.
online.
Or you can. Do you have a Scotia account, Lexon?
So it's Krishna, not Lexon.
Oh, sorry, Jesus have mercy. Sorry, there's a distortion with the car pass, and we can't hear that. Krishna, you have a Scotiabank account?
No, it's a NCB.
No
So you
problem.
can pay
You can
NCB online?
you can pay
No,
NCB online.
I
You know not token.
you know what? No, sir. Excel said them not doing the online thing.
No, sir. Not no go so.
Yes, sir.
Which part? When? Because online
Not
me,
no
I
go
gotta
so.
pay them.
When them tell you that, of course.
Krishna,
It told you already, you know, and ask.
Krishna. You see
Yes,
the
sir.
somebody we ask, they just have a nice flask of white rum, and then no, you should say, who you ask? The security guard ask?
No, sir.
I must security guard.
It's up
If
to
you
you.
they try to pay on area and it not go work,
You
but
guys
you can pay
anyone
with
pay it
online
online?
banking.
Anyone ever pay it online?
Yes, I have.
When?
Yeah.
Krishna, trust me, it can work online. You have the security guard ask, and if you ask the security guard, anything them tell you are good for you. You can pay it online. It's a pandemic, you know, Papa. And we're
Exactly because sir, if we have to do that to pay my light bill or whatever, everything would have cut off.
them that cut that off. Cause me now join online. Matter of fact, me don't even want to join. Say me hungry the other day. I want to go draw some money from the bank. And me see that me say you're lucky. Now go and go buy some porridge. And no join online for you crazy. I don't join line for food. You see me that church and them have anything yamins. And me see the line long. Me say who them I talk to? Me drive out and go to Burger King go buy my food and come back.
The
You have
IP.
money?
Or I mean, me not join online for no food. And them know me, them say, you know what? Come, not leave, because we know, oh, you stay now. You see all you, we can't deal with you, you know. Come meet you run at the window so we can eat something through the window. And them know me
You
because
think
me
it's
not
special?
join. Oh, I was born special.
So want everybody else.
Them only lucky, only can join line. Me not join the line. No man, me not join the line, man. No man, real talk. Me go bank already to go
Jamaican
draw some
people are
money.
impatient today.
No, I'm not impatient, you know. It's not impatient, but let me tell you, it's most likely you have COVID or so. And me want to go people for go rub up on them for go give them
Sir,
COVID
that
and
is
them.
my problem with Excelsior actually, because the other day them want me to come up there for a letter where them could email me. Me
Okay.
say, no.
No, miss sorry. To be honest with you, anyway, me I go know, and them said to me, I did some transaction the other day and I said, is that online? Matter of fact, I am a chairman for an institution and one big company in Jamaica. Now go call the name, one big company, multi-million-dollar company in Jamaica, having a conference at one place in a Portmore. Not even as a Portmore, a conference sort of setting area, right? I want me with my good self in this corona time to go in a conference room, lock up in a room with people with air conditioner and blow and so forth. I tell them, say me not go nowhere. I said, you're not having it online? They said, oh no, we're having face to face. I said, have a nice day. I said, have a nice day.
Insane.
So I don't care if you're going to have the Pegasus or the Hilton or sushi on the menu. Me can buy it. Me not do it. You have to be careful, guys. So I'm saying to you, Krishna, no. The truth of the matter is the online system works. That much I can tell you. It's when Excel is at fault, me are the first one to say no, them out order. But it's when me are the first one to jump on in the fence. The online system works. So go back online and try to pay it using your, just as long as you have tokens, just go ahead on NCB and just try to do the payment. When you get a receipt, then you can go as far as emailing a receipt to them for them to update the stuff, and you're good
Yeah,
to go.
that's what them say with the paymaster.
Yeah, nobody gonna pay master. You can pay it online.
But
Trust me on that. And if
payments
it
have
don't work,
online to Krishna.
and
Pay
pay
it
master online.
online.
Yeah, pay master.
Pay it
Pay master
online. What
online.
you do is write in the
ID number.
comments your ID number
Mm-hmm.
and your name.
Mm-hmm.
And then you take a picture of that and send it to Excel, sir.
Yeah,
Me
you
not
can check the
going
system.
into Excel,
Yo,
sir.
when I
I
paymaster,
don't even have on a new ID, sir. And to far as it, me not think that go phone a new ID.
I never
Talk truth.
use paymaster, so I never know I could have it online too.
Talk
Yeah.
truth. Did they go there no?
Yeah,
Come
so
I forgot for something.
the international line of Jamaican paymaster online.
Right, that's true. Did they go there forgot to do some transaction at school that
Okay.
is, and security guard said, ID please. Someone said, watch this now. My ID expired from almost about 2 years ago, you know. I took out the ID and hold it far from him and said, see the ID here? And him look on it. And the man said to me, and what is your name? I said, boy, I talk to me kind of strong still, you know, but you know what?
Yes, sure.
I got talk to him. So I said, my name is Shand. Are you a student or staff? I said, no, man, I take me too far, no, you know. I'm going to look on him and said, I'm a staff. Me can't see your face good enough. You're a staff? I said, Jesus, I'm father. I said, yeah, man, you're a staff. So come on, put the
Sir,
other
me know
side of
which
it.
security that.
But
But
sir,
I don't,
let me
go
search.
ahead.
They never, when I went there, they didn't search my bag. They just asked me for the ID number.
Me have to fly trunk a car to your talk about no search for that. Me have to fly trunk. And I say, how I keep? So I fly the trunk, because them tell us we have to comply, so I fly the trunk. And then after that, the man look at me and the man say, you are not staff, you are a student. So the man said, which section are you going? I said, I'm going to my office. Office? And I look on him and I say, you know what, today's going to be a very good day. I said, yes, sir. I'm a staff member. So I'm going to my office. I'm going to take this from my office. And then I'm going to be driving back out. I'm going to see him go over to him other friend. I'm going to know what him say to him other friend. And look at me and said, you alone have a wonderful rest of the day because me not in an argument with you because I want to just go in and come out.
I'm serious about the security thing, sir.
Yeah, man, we have to be serious. You know, what happened the other day was unfortunate. So we have to be very serious. So that's why I never even kind of rocks him up. You know, make sure say after two more visits, he may recognize the face. Man say, your staff? I said, yes, sir. But anyhow, peace and salutation. Walk good here. On the son of Jenko Jesus, Smith and Mile. And we'll have a wonderful rest of the evening into tomorrow. And then we meet up on Thursday.
You too, sir.
All right. Let's take care.
You too.
Yeah, man.